Hi, good day. I'm Kayode. I'm an online lesson teacher. I teach mathematics. You are welcome to QED Mathematics Online class. QED means quite easily done, and this is for GSS1 third week. And the topic we are having in Nigerian syllabus for the third week of GSS1 is lowest common multiple and highest common factor of whole numbers. So what we'll be looking at is the concept of L.C.M, H.C.M and L.C.M. We'll be talking about the L.C.M and H.C.M by inspection and by formula. And we'll be talking about the quantitative reasoning of L.C.M and H.C.M. The objective of this course is that at the end of this course, students should be able to obtain prime numbers and factors of given whole numbers. Students should be able to find L.C.M of whole numbers using factor method, multiple method, index method, and they are supposed to obtain the HCF of given whole numbers, and they are supposed to express the given whole number as product of its prime. Solve problems that have to do with quantitative aptitude using L.C.M and HCF as well. Study materials needed for this course are the counters and the multiplicative tables. Now, first, let us look at what L.C.M, what they are. At the same time, we want to look at what multiples are. Multiples of a number are given by multiplying the number with a whole number starting from 1. An example is given. Multiples of 12. 12 times 1 is 12. About 24. You have 36, 48, 60, 72, 84, 96, 108, 120. Continue. And multiples of 15, we have it from 15 to 150. And from 24, we have it to 240 on the screen here. That continues. We can have 12 times 11, 12 times 12. That is multiples of number. Now, what if we are not looking for the common or lowest common multiples of number? Look at an example is given here. We are asked to find the common multiple of 4, 12, and 36. At the same time, we are asked to find their lowest common multiple. So on the box below, you see the common multiples of 4, starting from 4 to 112, and then it continues. Multiples of 12 too, starting from 12. 12 times 2 is 24, 12 times 2 is 26, and that also continues. And we have multiple of 36. Now, looking at what we have on the screen, the common multiple of 4, 12, and 36, they are 36, they are 72, and 108. And we have more others as we continue with our multiple. But the least common multiple, the LCM of the three numbers, is 36. That is because 36 is the smallest or the least of all the common multiples we have in the 3 digits. So, therefore, we can say that the LCM of this 3 digits is 36. Okay, now let's look at another question. The question 3. We have to find the least common multiple or lowest common multiple of 27, 81, and 90. Let's look at the slide too. Yes. We use another method in solving this. We factorize 27, 81, and 90. We factorize it with our common factor until we get 1 or 2. So when factorizing 27 by 2, 81, and 90, we have 27, 81, and 45. So by the time we factorize down the table, we have our prime factors to be 3, 2, we have our prime factors to be 2, 3, 3, 3, 3, and 5. Multiplying all that together, we have 810. That is the lowest common multiple of 27, 81, and 90. That method is quite easy. When we consider the other method we use here, when we found the multiple of 27, multiple of 81, multiple of 90, this is not that easy. I think the first method we use here is quite easy to find the LCM of numbers. So the lowest common multiple of these three numbers is 810. And I believe the first method we use is quite simple. Now look at question 4. We have to find the LCM of 45 and 105. We have to use the product of their factors. It is solved. The product of 45 is 3 times 3 times 5. That's 3 times 3 is 9. 9 times 5 is 45. While the product of 105 is 3 times 3 times 5 times 7. 3 times 3 is 5. 5 times 3 times 3 is 9, 9 times 5 is 45, and 45 times 7 is 105. So the LCM is, we just multiply all the common factors together. We have 3 twice, 3, 3. Multiply that, we have 5 once, and we have 7. What that gives us 315. You can use the two previous methods in solving this, and you get the same answer. So that's all about LCM. It's quite easily done, quite simple as well. So if you have any question, you can contact us and we'll answer your question promptly. Then we move to HCM. HCF, highest common factor. Yes, all numbers can be expressed as a product of their factors. And let's look at an example. Let's find the factors of 84. 84 is 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. That's because you can see the right hand side. You have 1 times 84 is 84, 2 times 42 is 84, 3 times 28 is 84, 4 times 21 is 84, 6 times 14 is 84, 7 times 12 is 84. All these are factors of 84. So you can do it this other way. That's all. You can factorize by the common point, by the point factor. 2 can divide 84 without a remainder, so you have 42. 2 can as well divide 42, that's 21. 2 can divide again, so you divide with 3. Then 3 and 21 is 7, and 7 will divide 7 one time. So that is the point factor of 84. 2 times 2 times 3 times 7. And this can be represented in index form. That will be 2 raised to the power 2 times 3 times 7. This is just the common factor of 84. Now let's go into HCF, highest common factor. This is an example. We have to find the highest common factor of 21, 63, and 105. Yes, the factors of 21. We have 1, 3, 7, and 21. In some methods, you won't put the 1 because 1 is constant in all. Then in 63, we have 1, 3, 7, 9, 21, and 63. Then for 105, we have 1, 3, 5, 7, 15, 21, 35, and 105. I'm sure by now you know how to find your factors. Now, out of all these factors we have some that are common. The common ones are 1, 3, 7, and 21. And the highest is 21. So therefore you can see 21 is the highest common factor. And this is another method of solving it. We can factorize to find the prime factors, and from there we have our common product, which is the HCF, to be 21, and method 2 and method 3. So that's what we'll take today for JSS1 third week. If you want have any question in this, you can send a message to us on our WhatsApp or on our email. Thanks for watching. Remember, this is quite easily done.